Solve the following LPP graphically. Maximize z is equals to 4x plus y subject to the constraints x plus y less than or equals to 50, 3x plus y less than or equals to 90, x is greater than or equals to 0, y is greater than or equals to 0. To solve such problems, we will consider the constraints one by one. First constraint is x plus y less than or equals to 50. So consider a table. X, y. So if suppose if x is equals to 0, so y will be equals to 50. So we have got a point 0 comma 50. If y is equals to 0, then x will be 50. We have got another point 50 comma 0. So these are the points to construct this constraint on the graph. Next constraint is 3x plus y less than or equals to 90. Again consider a table. X, y. If suppose x is equals to 0, this term will be eliminated. So y will be 90. So we have got a point 0 comma 90. Then if y is equals to 0, 3x will be equals to 90. Then x will be equals to 90 by 3, which is 30. So we have got another point 30 comma 0. So whenever we are given such a problem, first we have to consider the constraints, and then we have to construct these tables. Now we'll construct the graph of these constraints. As you are observing, we have a point 0, 50, 50, 0, 0, 90, 30, 0. So the points are in terms of tens. So we can consider scale in terms of 10, 20, 30 till 90 we need. So 10 points I'll be considering. You will be given a graph sheet, so you can directly consider in the exam. Since I don't have a graph sheet, I'll be doing like this. Same with respect to x-axis. Since there are no negative points, no need to consider negative x-axis and negative y-axis. Just you can consider like this. Make sure you're marking the points properly, otherwise you'll not get a proper solution. Boundary points will vary if you're not considering the scale properly. So since we have 50, 90, 30, I'll take 1 centimeter. I'll write the scale over here. Scale, x-axis, 1 centimeter is equals to 10 units I'm considering. Similarly, y-axis, 1 centimeter is equals to 10 units. 10, 20, 30, 40, 50, 60, 70, 80, 90. So this is our x-axis, x dash, y, and this is our origin. So here also 10, 20, 30, 40, 50, 60, 70, 80, 90. So now we'll consider the first constraint, that is x plus y less than or equals to 50. So the points are 0, 50 and 50, 0. You should not consider like this. X and y below only you have to consider, because any point in the coordinate system will be represented as x, y. So now 0, 50 is there. X is 0, y is 50. So nothing but here the point lies over here. So we'll write down the point 50, 0. So 50, 0. We have considered the points. Now take a scale and join these two points. Now write down the name of this constraint, that is x plus y less than or equals to 50. So less than means towards the left side you have to shade. I'll just shade it roughly. Now the second one is 3x plus y less than or equals to 90. The points are 0 comma 90 and 30 comma 0. So this is our 0 comma 90 and this is our 30 comma 0. Make sure you are completing one constraint and moving on to the next one. So first writing the lines then shading will not solve the problem. It will become complicated. First complete the constraint which is given first and then go for the second one. So first one is completed. Now I'm going for the second one. So I've joined the points. So after joining the points, immediately write down the name of this constraint, that is 3x plus y less than or equals to 90. Even this is less than, so towards the left side only you have to shade. So now comes the concept of feasible region or where the solution lies. So if you are observing, both the solutions are coincide here. Solution regions are coinciding here. So shade that region, highlight that region. So this region is called feasible region. Once you get the feasible region, just write over there. That is the feasible region. Now around the feasible region, whatever the corner points are there, boundary points, just mark them. So this is our origin, which is 0 comma 0. This is already written 30 comma 0. This is 0 comma 50. Only this point we should be finding out. So if you are observing, x value is 20 over here, y value is 30. So this point is 20 comma 30. So we have got all the boundary points. Now we have to maximize and minimize. Nothing but maximum value we have to find. Let us check. Since there are 4 boundary points, we have to consider 5 rows and 2 columns. So first row will write boundary points and the corresponding z value here in the second column. So first boundary point is 0 comma 0. Nothing but x is 0, y is 0. Second one 30 comma 0. Third one 20 comma 30. Fourth one 0 comma 50. So I've considered all the boundary points. Now 0 comma 0 means x is 0, y is 0. So if I substitute 4 into 0 is 0 plus y is 0. So 0 plus 0 is 0 only we have got. Next 30 comma 0. If I substitute 30 comma 0, 4 3 is a 12. So 120 plus 0 we will get, which is 120 again. Next 20 comma 30. So 2 4 is a 8. 80 plus 30, which is 110. Next z is equals to, so 0 comma 50 means 4 into 0 is 0 plus 50, which will give you 50 only. Since they have asked maximize, so here if you are observing, the maximum value is 120. Just write max over here. Now the conclusion is very, therefore the maximum value of z is 120 at what point it is 120? 30 comma 0. So if you write this much, you will be getting 6 marks. Next problem, solve the following LPP, minimize and maximize z is equals to 3x plus 9y subject to the constraints x plus 3y less than or equals to 60, x plus y greater than or equals to 10, x is less than or equals to y, x is greater than or equals to 0, y is greater than or equals to 0. The meaning of this is the solution lies in the first quadrant because both x and y will be greater than or equals to 0 in the first quadrant. So now we have to consider table for these 3 constraints. So let us do x plus 3y less than or equals to 60. So this is the first constraint. Let us consider the table for this. X, y. So if x is equals to 0, so this term will be eliminated. So y will be equals to 60 by 3, which is 20. So we have got 0 comma 20. So next, if y is equals to 0, then x will be 60. So we have got another point 60 comma 0. Next constraint is x plus y greater than or equals to 10. So let us consider table. x, y. So if x is equals to 0, y will be 10. We have got a point. Immediately you should write down the point down. Next, if y is equals to 0, x is 10, which is 10 comma 0. So in the previous problem we had only two constants, so two tables we have considered, but here we have one more. So x is less than or equals to y. If you take y towards the left side, we will get an equation or inequality x minus y less than or equals to 0. So we'll consider the third constraint, x minus y less than or equals to 0. So here if you are able to see, x is almost equals to y, x is less than or equals to y. Whatever is the x value, same will be the y value. So if you take x is equals to 0, y will be also equals to 0. Such equations are called as the equation passing through the origin. So we need a graph. So for that, what I'll do is, like the previous problems, I'll not consider 0 for x and y. Instead, I'll consider some 10, 20. So that we'll get 2 points for the construction. I'll consider x is equals to 10. Then y will be also equals to 10 because x is less than or equals to y. If I consider 20 for x, then y will be also equals to 20. By seeing the values of all the three constraints, we have the points 20, 60, 10, 20. So I've considered the scaling as 1 centimeter is equals to 10 units for both x and y axis. So first constraint 0, 20, 60, 0. So x is 0, y is 20. So I mark the point 0, 20. Next we have 60, 0. So I'll join these 2 points. Now immediately write down the name of that constraint, x plus 3y less than or equals to 60. Since it is less than, towards the left side we have to shade. So now the next constraint is 0, 10, 10, 0. These are the 2 points we have. This is 10, 0 and this one is 0, 10. Join these 2 points. So the constraint is x plus y greater than or equals to 10. Greater than means towards the right side we have to shade. There is one more constraint, that is 10, 10, 20, 20. So 10 and 10. So the point will come over here. I mark the point 10, 10. Next we have 20, 20. So x is 20, even y is also 20. So as I was telling, this type of inequalities will pass through the origin. X is 0, then y is also 0. So now we have to join these 2 points in such a way that it will pass through the origin. So I'm joining these 2 points passing through the origin. Now write down the name of this constraint, that is x minus y less than or equals to 0. So less than means towards the left side of that line. So I'm just shading this. So if you are observing, the common solution or the feasible region is this one. So call it as feasible region. So now mark the boundary points. So here there are 4 boundary points. One is 0, 10, another one is 0, 20. So here if you are observing, so in between here, in between 0 and 10 it is there, which is 5. So here also this is 5. So the boundary point is 5, 5. Here 15 and 15, we can easily see the boundary point 15, 15. So I will list down all the boundary points and find the corresponding z value. So since there are 4 boundary points, I have listed all the boundary points 0, 10, 5, 5, 15, 15, 0, 20. Now we'll substitute in the place of x and y and find the z value. So 3 into 0 is 0, 9 into 10 is 90. We have got 1 point. Next 5 and 5. 3 5s are 15 plus 9 5s are 45. So 45 plus 15, 60 we will get. Z is equals to 15 3s are 45 plus 15 nines. So we'll be getting 180 if we had. Then 0 comma 20. So 3 into 0 is 0, 9 to is 18. So we'll be getting 180. So here they've asked for both minimize and maximize. Clearly this is the minimum value. So write it as minimum, and this is the maximum value. Write it as maximum. So now writing the conclusion is very important, which carries 1 mark. Therefore, the minimum value of Z is how much? It is 60. At what point we have got 60? 5 comma 5. Next, maximum value. So the maximum value of Z is 180. We have got 182 points. We have to mention both at 15 comma 15 and 0 comma 20. So if you write this much, you will be getting 6 marks for this.